Goedenavond. I was so excited about being able to say good morning, and then Harold came up and gave you like a paragraph. So now I'm feeling a little insufficient. So welcome, welcome. I'm very excited to be here today. It's not often that I get to do a presentation in a palace, so that's pretty exciting for me. And today I'm going to be talking to you about the future of design. One of the things that Autodesk has near and dear to our heart is the belief that we are really here to create tools for you to help you imagine, design, and create a better world. And today I'm going to be talking to you about some technology that I believe is definitely going to help us create a better world. And some of this has already been discussed. I'm going to take a slightly different angle towards it, but I'm going to be focusing on design in the cloud, reality capture, and then we're also going to take just a slightly different look at the world of 3D printing, which we've heard a lot about today. So to start this off, I thought I'd jump in to the world of the cloud. Now, we hear about the cloud all the time. We hear about the iCloud. We hear about the Microsoft cloud. We hear about so much technology related to the cloud. But the cloud can actually be a little bit confusing. So many different definitions, so many thoughts around it, so much software that's supposed to run on the cloud. But I thought I would just ask you a very simple question. Do you know why we call it the cloud? Why don't we call it the sun, or the moon, or the carpet, or whatever we might come up with? Does anybody know why we call it the cloud? I've actually never been in a presentation ever where anybody knew the answer to that question. So I thought that I would just give you a little bit of background on why this amazing technology is called the cloud, just for starters. So the reason we call it the cloud is because of this gentleman here. He was a Stanford professor. His name is John McCarthy. And back in the year 1961, he predicted that someday computation would be organized in the same way as a public utility, which really still doesn't explain why we call it the cloud. So he believed that someday that we would literally be able to access our software kind of the same way we access our utilities, like our electricity, right? We plug in, and we can access our electricity, or we unplug it, and we're not accessing it anymore. And technically, we only have to pay for the utilities that we use at any given time. Still doesn't really explain why we call it the cloud. Well, it turns out that he was actually referencing the telephone industry. Here's a very old picture of the old telephone network. And in the very early days of the telephone industry, guess what? They called it the cloud. And that is why, to this day, we refer to this technology where we can plug in, we can access this software, we can access all that amazing computational ability as long as we have access to the internet. That is why we call it the cloud. Now, I'm going to guess that we probably have some AutoCAD users out there, so I thought I would share with you a very interesting connection between John McCarthy and AutoCAD. This gentleman here was also known as the father of artificial intelligence. He is the man who wrote the programming language Lisp, and some of you may actually know how to do some Autolisp programming inside of AutoCAD. And a very long time ago, some of you may remember this, or you may have seen it in movies, he also invented the game, the chess game, that allowed you to play against yourself on the computer. So he was a brilliant man, and definitely was the person that set this whole concept of cloud. So then what does the cloud look like? So we know why we call it the cloud. What does it look like? It doesn't look like that. The cloud that we've been talking about looks a lot more like this. We have 50 million servers worldwide that as long as you have an internet connection, you can actually access that computational ability. And that number grows every day. So I'm going to kind of talk about the three main reasons to use the cloud. This is according to Lynn Allen, and maybe you have read differently. But I believe that the three main things that we care about in the design industry would be, one, the mobile application of it, the ability to store and access our data from anywhere, the collaboration aspect, which I think is very, very powerful because now we can design from anywhere in the world with anybody in the world, once again, as long as there's an internet connection. And the computing power aspect, by far the most powerful. Being able to access those 50 million servers, no longer being restricted to the hardware that your boss decided that you were worthy of. As long as you have an internet connection, you can do some very complicated things up in the cloud. So let's start off by talking about mobile. So I'm sure that many of you have tablets. Actually, by a show of hands, how many of you have tablets? It will take a while for the translator to catch up there, okay? And how many of you have smartphones? More hands go up. So it's believed that the tablet of today has the same computational ability as our computers from 10 years ago. And I don't know about you, but I predict that in the future, not too far future, that the tablets will become more and more powerful. And it's foreseeable that perhaps at some point in time, maybe we will do our work on a tablet at some point in time. So I thought I'd show you this video. There's sound on this video for you guys over there, if you can get the sound on. Take a look at our next generation. This is a baby under the age of a year who is using a tablet. And then she goes to work with a magazine. Can we get a little bit of sound? There's sound on there. Yes. Just kind of pointing out how the tablets of today are second nature to the children of today. This is my favorite part. She thinks maybe perhaps her finger isn't working right. Maybe there's something wrong with her finger. No, it's still working. It must not be my finger. So the point of that is that our generation of today doesn't even think about this technology called the tablet, and in the future, they're going to expect that the tablet will be very actively involved in their lives. I also love this picture. This is back in 2005 with the Pope's inauguration. You'll see maybe a couple of phones that have the capability of taking a picture. Let's take a look at what happened in the year 2013. You see tablets, you see phones. Technology has definitely changed in the last few years. So let's take just a look at a chart for technology adoption. If you take a look at the telephone, you can see back in the early 1900s, technology was still fairly new to us. So we were a little hesitant to adopt something as amazing as the telephone. You can see some other technology that came along over time. You can see that we became a little more accepting of technology and tried it a little bit more. You can see here refrigerators. Everybody got that. Everybody jumped on that right away. Anything to keep their food cold, that made sense to them. But you can see electricities and cars and things like that. They were adopted a little bit faster. Here we have some other technology. You'll see that the color TV caught on very quickly because we already had black and white TVs. That was pretty much a no-brainer as long as you could afford it. I, of course, am a big fan of the dishwasher. I'm surprised that that isn't a much sharper curve, but that's okay. The point of this is, though, I'd like you to take a look at tablets and smartphones, of course, computers, and other things like Facebook and the internet. And just to make it more clear to you, you can see that we accept technology. We realize that technology is going to change. We're much more willing to jump on the technology bandwagon, and for some of us, can't even get enough of this cutting-edge technology. This is an example, and you saw something very similar to earlier, going back to the whole concept of the cloud and mobile. Being able to take technology, take it into the construction field. Up until now, 90% of all technology in the construction field stays in the trailer, or it stays in the office. Only 10% makes it out to the field. This is a perfect example where using a tablet, using Autodesk BIM 360 field, that you have the ability to find out information in the field, in this case about a pump. You can see if there were any quality issues with the pump. You can find out about the installation. You can actually take a look at the model and make sure that it was installed properly. Amazing technology. Okay, let's move on to collaboration. So we hear a lot about A360. It used to be Autodesk 360. We recently rebranded it. How many of you have an Autodesk 360 or an A360 account? You've gone up there, you've taken a look, you've opened an account. Okay, good. So A360 is absolutely free. That's the best part of it. And everybody has access to this great technology. It's built into almost all of our programs so that you can take advantage of it. So at the very lowest level, and I'm going to say this is the very lowest level, if you were to say, what does A360 offer? It is the most amazing backup program. I think of it like as the Dropbox for design. For example, you can have it set up. So if you're inside of Revit or AutoCAD or Inventor or Civil 3D, pick your Autodesk product of choice. Every time you do a save, it will save to your local computer or your internet, or excuse me, or your network, depending on where you normally save it to. And then it will also save it to your A360 account. It's a great backup program. You don't even have to think about it. You can set it up so it does that automatically. And then imagine maybe the next day you're at home, you're not feeling well, but you need to make a change to the Revit model. You can just log on to your A360 account, make those changes. You can send a note to your manager saying that you made the changes. You can allow him to have access to the model, and then you can go back and get some bed rest and take care of yourself. So that's the very lowest level, and I'm sure the people in the A360 team would have a heart attack if they knew that I was telling you that this is one of the things that you can do with it, because there's so much more potential. If you are not on subscription, everybody who has access to A360 gets 5 gigabytes of space. If you happen to be on subscription, you get 25 gigabytes. But let's take a look at some other things that you can do with A360. If any of you work on Revit, you know that the larger the Revit model, the slower it goes when it comes to viewing. This is a 1.5 terabyte Revit model. I want you to notice how fast you can display it, how fast you can zoom in. You'll see a little bit of degradation as it spins around, but it's amazingly fast. You will find that A360 now harnesses the showcase technology, if you're familiar with that product, to do almost instant rendering, and makes it very easy for you to share your models with anybody and to view them very easily. It's not just about sharing your models and visualizing your models. You will also see that A360 allows you access to data. So you can go into the models and find out the information that's so important to your designs. I think that's good enough. Let's switch over a little bit to manufacturing. So A360 is really focused all about projects, very project focused. And you can decide who's on the project, and it works kind of in the same fashion that many of us are familiar with as far as Facebook is concerned. So here we have A360, and let's say we have a project for this robot arm. I need to make some modifications to it. I can simply click on the model, and I can open it up in a program called Fusion 360. If you're in the manufacturing truck, I'm sure that you will hear all about that today. I can make my modifications to the model, and then I can put it back into the project team's information to show everybody that I made some modifications to the model. Okay, so now that I've made some modifications to the model, maybe I need to do some simulation to make sure that it still supports the design changes. So if I click on it again and I decide I want to do something related to simulation, it will take me into Sim 360, and I can do a good check of it. And as we know, red is bad. There's a little bit of red, so I might have to make some changes accordingly. Let the design team know I did some simulation. Let them know if I need to do some changes. And then also, always important is the documentation aspect. This is AutoCAD 360, an amazing program. How many of you have used AutoCAD 360? AutoCAD 360? Really? It's free. It's absolutely free. How many AutoCAD users out there? AutoCAD users? AutoCAD? AutoCAD? Are you shy? AutoCAD? All right, good. All right. AutoCAD 360, even if you're using Revit or if you're using Inventor, sometimes we go back to documentation inside of AutoCAD. AutoCAD 360 allows you to take your designs anywhere, going back to that mobile aspect. Amazing technology, absolutely free. Don't have to print out your designs. All you need is a tablet. But it's great because you can convince your boss that he should buy you a tablet so you no longer have to print out your designs because you want to be ecologically friendly. You want to save all those trees, right? Amazing technology. I'm always curious how that gets translated. All right, so the part I believe is the most exciting about the cloud is the fact that you can do things that you never could do before, because the cloud is great at processing large amounts of data with multiple variables. Let's take a look at a couple examples. So I actually took this picture when I was in South Africa at a university down there. This is a picture of a little note that was written by a student where basically they were like, don't touch the computer because the computer is rendering. I'm sure many of you have done rendering. I'm sure that some of you have had renderings that lasted for hours, sometimes for days, and sometimes for weeks. This is a perfect example where cloud technology comes in handy. So we have Autodesk Rendering 360, which allows you to take all the information that you need to do rendering and put it up into the cloud. Doesn't matter what kind of computer you have. Doesn't make any difference as long as you have access to the internet. Take that information, hand it over to Autodesk Rendering 360. You go on your way, continue to use your computer, and if you've ever done rendering, you know it's very difficult to use your computer when it's doing a rendering, right? Because it really slows it down. Put it up into Autodesk Rendering 360 and something that used to take 24 hours down to less than 24 minutes. Fabulous technology. A great example of the cloud. BIM 360 Glue, another great example of cloud technology. Something that perhaps took hours and days in the past, or maybe you wouldn't even bother doing online, such as clash detection, easily done up in the cloud. And one of the things I love about BIM 360 Glue is it doesn't really care about your file type. Not everybody works in the same software. BIM 360 Glue supports 50 different file types, and they're not even all Autodesk products, which allows you to work easily with other people on the design team. So in this situation, it found some clashes. It can highlight the clashes. You can send emails to members of the design team and let them know where there was a mistake. Ask them to go in and correct the clash. And then you can run another simulation to check it. Because sometimes when we fix one thing, we often break another. So you could continue to check it before you ever got to the construction phase. Going back to manufacturing, how great would it be to be able to do simulation as you were designing? Here we have a headset, and we're going to check it out. We already designed it. Let's check it out to see how it looks, and there was too much red, right? Wasn't going to be able to handle the stress of that design. So while you were designing, you can make modifications to the model and continue to check it to make sure the integrity is high. All right, we're going to move on to reality capture. So I'm a big fan of reality capture. So this is a building where just by simply using photos, they were able to use Recap Photo to take those photos and put them together and create a 3D design. This is a model that you could take into AutoCAD, you could take it into Revit. Very powerful technology. This is a point cloud. We like to spin our buildings a lot at Autodesk. So always a lot of spinning. So let's talk just a little bit about Recap. If you installed any of the Autodesk Hero products like Revit or Civil 3D or Inventor, you installed, unless you were paying attention, you might have installed Recap. It's part of the automatic installation process. Absolutely free. For those of you who use point clouds, it's a very powerful program. It allows you to take point clouds, which are very, very large files, often billions of points, to take those files and streamline them and help you put them together into a 3D model. So often when we design, we start with an empty page. Wouldn't it be great if you didn't start with an empty page, but if you could start with the realistic condition of whatever it is you're designing? This is, you saw something very similar to this earlier. This is a tech shop in San Francisco area. And we just want to make some modifications to the existing tech shop. And what if I don't have an AutoCAD file? Or what if I don't have a Revit file? Or whatever industry you happen to be in, I can actually use a 3D scanner to go in and take a picture of the existing environment and actually bring that information into our products. So as I mentioned to you before, we typically start with a blank sheet of paper. Everything, though, starts with an existing environment. Reality capture allows you to design in context. So So if you were to take a look at some of our previous products back in 2013, we were able to bring point clouds in. They were slow, and they were black and white. The maximum number of points that you could bring in is 2 billion. Sounds like a lot. Trust me, it's not. Now you can bring in over 20 billion points into Revit, into Inventor, into AutoCAD, into Civil 3D. So here's an example of that same tech shop. I just want to go in and I want to add a wall and a door. Once again, I don't have an existing documentation on it, so I will scan the room and then using recap, streamline those point clouds, bring it into Revit, and then simply add in my wall and my door. There you have it. So in this situation, we have Revit objects, and we have a point cloud put together. Spinning, remember, lots of spinning. So we recently set up an alliance with GoPro. Some of you might be familiar with GoPro. Here we have a bunker in San Francisco. We don't have any documentation on it. If I wanted to make modifications of it, I'd have to measure it, and I would have to create some type of documentation in Revit or AutoCAD, or once again, pick your software of choice. So I'm going to show you this very cool video. And I'm going to tell you also, the person that did this had only used Revit for 2 days, just to give you some idea. So he's going to go out, and he's going to, using a quadcopter, capture the bunker. Watch out, it gets really loud. Hopefully, if we have sound this time. We'll see. Sound. Can we get sound, you guys? Because we had sound earlier. You guys want to dance, right? Every 1.5 seconds, they took a picture. See all the camera angles up there? There's the point cloud. Lots of spinning. Design changes he's suggesting. Some studies. The most important part is the ending with the dog, so. It's amazing technology. Absolutely amazing technology. So I'm going to end it. We're going to talk fairly quickly here because I'm going to be running out of time. A little bit about 3D printing, the rise of personal manufacturing. It was such a big deal when we had the Industrial Revolution and we could manufacture dozens and hundreds and thousands of products at one time. I kind of feel like now we've kind of come full circle and we're back to kind of one-offs, personal manufacturing that you can customize any way that you want. And of course you heard earlier about Ember, the new 3D printer that Autodesk is going to be eventually at some point offering to anybody that wants to purchase it. The cool thing to me about this is that it's based on an open platform, Spark. Anybody can jump on that platform, and the technology that's going to go behind the 3D printer, we're going to make it absolutely available to anybody who wants to work from that. So we're really trying to open the door to the land and the world of 3D printing. So it used to be that 3D printing was basically based on ABS plastic. If you wanted something out of plastic, you were in good shape. But now we're using so many different materials to do 3D printing, including not on here, stainless steel and organic materials, which we'll talk about in just a second. And 3D printing allows you to definitely personalize things in your life. Here we have the Nike shoe. We saw this a little bit earlier. You have the ability to go to the Nike website, and you can select a shoe of your choice. You can tell it the color, you can tell it the style, you can tell it you want it for running or walking, or whatever the situation is. But using the 3D printing process, Nike will be happy to customize that shoe for you and send it out to you. Of course, for a fee, but nevertheless. This is a 3D printed dress. This is something that 3D printing really works well with, being able to customize it so it completely fits you and only you. You can take your measurements, your dimensions, you can hand it over to the 3D printing process and design something specifically for you. We saw jewelry earlier as well. Amazing technology. I want a guitar that works perfectly to fit me exactly what I need. This is a 3D printed plane. We saw a 3D printed car earlier in the presentation. And probably my favorite, the world of bioprinting. Imagine if we could print organs, if we could print kidneys or livers, or maybe even someday a heart. So many people die every year because they don't have access to a specific organ. They wait in line for days, for months, for years sometimes, and never receive the organ that they need. Imagine if we could somehow print organs. And let me tell you, this is very, very real technology. The process is fascinating, actually. I've done a lot of research on this. I find it personally fascinating, where you take an MRI of perhaps somebody has a kidney and it's not functioning. They could take an MRI of it so they can make an exact match. One of the problems with organs is that your body often rejects them. So we will use organic material, including some of your own living cells, to make sure that that particular organ is not rejected. Amazing, amazing technology. And the way 3D printing works, it's layer by layer by layer by layer, very, very, very thin layers. Perfect. A perfect use would be if we could somehow print organs. Right now, they're talking about, it's not this slide, something just as simple as being able to print like a variety of like discs in your back or valves, something simple like that. You know, my dad just went in for open heart surgery and they gave him a cow valve in his chest. But imagine being able to do a 3D print of the one that he had and make sure it matches perfectly. This is technology that's right on the horizon. So this situation isn't exactly bioprinting, but they were able to take an MRI of this 2-week baby-old heart, and they were able to generate a 3D model of the baby's heart. The baby's heart had a variety of holes in it. Now, normally, in order to fix this, they would have to do several surgeries. The first one involves going in to exactly figure out what they need to do to fix it, and then over time, they would continue to do surgeries until they got it right. As a result of this, the doctors were able to look at the heart ahead of time, figure out what they were going to do to fix it, and they were able to go in and do one and only one surgery to fix the problem. Now imagine you as parents, if you knew that this was a possibility because of 3D printing, that's a pretty powerful step in the right direction. And just kind of mentioning to you, I know this is difficult to read, but just some of the things that they're taking a look in the next 2 to 5 years, being able to do those discs like I talked about, vertebral discs, meniscus tissue, being able to do 3D printing right on skin for burn victims and things like that. In the next 10 years, they're talking about some of those valves, like the heart valve I was talking about, and eventually they're hoping to be able to print some of the more significant organs. So another thing that makes sense, if you can truly customize a 3D print would be along the lines of artificial limbs. So here we have a boy by the name of Kamal. And at the age of 14, he was in a motorcycle accident and lost his leg above the knee. Every year, 3 million people lose their legs above the knee. It's a very difficult prosthesis to create. Now, if it turned out, and actually, it's not uncommon, you might think it's landmines and things like that, but actually it's auto accidents and motorcycle accidents that cause the most amputations of that particular form. So I know that in the US, if someone in the military lost their leg above the knee, they would get a prosthetic given to them by the government, and that prosthetic cost about $20,000. Kamal's family makes $40 a year. They're never going to be able to afford a $20,000 limb, and as a result of that, he has been walking around with a bamboo stick and trying to negotiate that way. If you were to take a look at the next level down, you're looking like at a $2,000 limb, all the way down to an $800 limb. An $800 prosthetic only bends in one direction, kind of like a door hinge. It's very loud, very noisy, very, very difficult to work with. So he chose the option of the bamboo stick. So this company called D-Rev created this amazing Jiper knee. They can 3D print his current leg, make sure it fits perfectly, and for the price of $80, they created an amazing new knee for this gentleman and thousands of others. It's simply made up of 5 pieces of plastic, 4 nuts and bolts. It's very, very quiet. They realized one of the issues with the other knees were that they were kind of noisy and clicked, and they want people to maintain their self-respect, so they make it very quiet. High range of motion. It doesn't just work in 2. It goes 3 different ranges of motion, which allow them to do things like kneeling and squatting and even praying or biking, whatever the situation is. Very durable. You don't need any special tools to put it together. And it's very, very lightweight. It weighs less than a pound. So this company has changed his life and many other amputees' life. And I love that about 3D printing. So to wrap it up, once again, our vision at Autodesk is to help people imagine, design, and create a better world. And we're hoping that as you attend Autodesk University Extension today, that you will get some new ideas, you will be very optimistic about the future of design, and you'll start to think about how you can do exactly that and to create a better world. Thank you so much for your time.